All right, I'm just going to write here at the top November 2022. Okay, now guys, they studying history while watching maths. Yeah, you're writing history tomorrow, hey? Shame. Good luck with that, guys. All right, so 10.1, they're saying A, B, and C are three events. The probabilities of these events or any combination of them occurring is given in the Venn diagram below. All right, so they've given us all these probabilities. They haven't given us the probability of all three events happening, and then they also haven't given us the probability of none of these events happening, right? So in the first question, 10.1.1, they're saying if it's given that the probability that at least one of the events will occur is 0,893, calculate the value of first y and then x. Now guys, we need to think, obviously they've given us this value for a reason, right? That at least one of the events will occur is 0,893. Now guys, at least one of the events will occur. That covers this entire space that we have, all three of these circles all together. Because if only C occurs, right, if we're just looking at this Venn diagram, this amount here, or this value here, is C only, right? But if C only is happening, then that's at least one of the events. If this value is, if we're looking at that probability there, that is the probability of C and A, but not B, because it's excluding B, of C and A occurring, only C and A, that's still at least one of them, right? Even if we're looking at that probability there, the probability of all three of them occurring, that is still at least one of them. So actually all of this is equal to 0,893. So if they're asking us to find y, what should all of the probabilities in an entire completed Venn diagram equal to? If they've given us probabilities, right? They should all add up to 1. Yes, Dylan, absolutely correct. So what we're going to do to get y, we're supposed to say 1 minus all of this, which they are telling us is 0,893. Right, so for 10 point, oh, sorry, I want to do this in black. For 10.1.1a, where they're asking us for y, we're going to say 1 minus 0,893, which is, if you round it to 3 decimals, if you just do that subtraction straight from there, it's 0,107, or it's also fine if you round it to 2 decimals. That's actually what they told us to do. So people are asking why 1. Remember, guys, the probability of everything in a Venn diagram should be 100%, right? Because if we include all of the outcomes, then that is everything. So it's all of them. All right, so since we're working with probabilities here with decimal values, the sum is going to have to be 1. If we were working with percentages, it would have been 100%. Right, now someone was asking what about x? Well, x is included in at least one of the events. So x is included in the 0,893. Right, and that is in fact the next question, guys. They're asking us now to find x. Now what I'm going to do is I'm just going to actually write here that this is 0,107. Now, if we need to find x, if we're looking at the 3 circles that we have all of the probabilities in these circles except for x, right? And we know that all of these values are supposed to add up to 0,893, which they've given us. So we can calculate x by taking 0,893 and subtracting all of these values. Right, so we're going to say x is equal to, now it's fine if you don't write this step down. I am just going to write it down so that you guys can see what I'm doing. But in the exam, you are absolutely, it will be fine if you just type them into the calculator and get the answer. So I'm subtracting that one, that one, that one. Now I must still do 0,1 and then 0,2 and then 0,183. And I do have the answer here already. That is 0,61. All right, where is the 0,11 from? That is just this rounded to 2 decimals. If you wanted to round this off to 2 decimal places, because that's a 7, you'll round that 0 up to a 1. right? But it's fine if you leave it like that. Okay, so that is the value of x, guys. The value of x is 0,61. I'm just going to erase all of this, and then I'm actually going to fill that value of x in there, right? So x is 0,61. Okay, now in 10.1.2, determine the probability that at least 2 of the events will take place. Where did I get 0,893? That was given in the question. They told us the probability that at least one of the events will occur is 0,893. So that is all of these values that make up the circles, the Venn diagram, the circles, events A, B, and C. All right, the probability that at least 2 of the events will take place. So now we need to, on the Venn diagram, guys, if it says at least 2, that means that we can't have only one event happening, right? We can have 2 events, but we can also have 3 events, because if 3 of them are taking place, that is also at least 2, right? So on this Venn diagram, we're going to have that one, because that is A and C. This one, that's A and B, that's 2 events, right? B and C is 0.2. Answer is 0.16. Oh, yes, you're right. Sorry. Absolutely. Thank you so much. I swapped them around. Thank you. Thank you. Appreciated. 0.16. Thank you so much. Right? Okay. Are we all with what's happening? I just made a mistake there. I just swapped my numbers around. Sorry about that. Okay, so back to what we were doing. At least 2 of the events. So that is A and C, that's 2. A and B, that's 2. B and C, that's also 2. But guys, we have to also include all 3 of them. All right, because for all 3 of them, that is also at least 2. So now, since they're asking for the probability that at least 2 will take place, these numbers are all already probabilities, so we can just add them together. I'm just going to write here probability at least 2. You don't have to do this little introductory thing. You can just give the answer. Yes, the video is on YouTube already. So I'm just adding them together. Again, you don't have to write this step down that I'm writing now. You can just do it on the calculator and write your answer. And this is 0,61. There we go. All right, you do get full marks for only the answer only. Okay, are we with, guys? Are we understanding what's happening here? 10.1.3 is a very common question, and it's nice because it has a specific layout that you need to do. All right, so 10.1.3 are events B and C independent. Justify your answer. So now you need to know how to prove that. Okay, there is a very specific way of proving that. 2 events are independent if the probability of, since we're talking about B and C, if the probability of B and C is equal to the probability of B times the probability of C. Yes, 0,16 is for all 3, absolutely. But if you're saying at least 2, 3 is also at least 2. At least 2 means 2 or more. All right, so you have to include the part where all 3 of them is also. So that is also going to be at least 2. All right. So what was I doing? We need to prove this. Okay, that is what is true when 2 events are independent. So, guys, very important. You have to do this in 2 separate calculations. You can't approach this as an equation where you are doing both at the same time. Hello, Asad. How are you? All right, so we're going to say probability B and C. How did you know I was live? Okay, let's look at probability of B and C. So where is B and C overlapping? Let me actually just erase this highlighted or these highlighted bits that I have here already. The probability of B and C is where B and C overlap. So that is B and C, right? We have to include both parts of that overlapping bit. I'm fine, Asad. Thank you for asking. All right, so that is 0,16 plus 0,2, which again, you don't have to write down. If you don't want to, you can just write the answer, but that is going to be 0,36. So I have already done a live on finance. It's on my YouTube. It's like an hour long, I think. We did that on Monday. All right, so that is the first half of the statement that we've done. Okay, now probability of B times probability of C. We now need to do that in a completely separate statement, not where the two events are overlapping specifically. We're doing probability of C on its own, and then we're multiplying the probability of B also on its own together. So if we're looking at this Venn diagram here, the probability of C, guys, that is the whole C circle, right? That is the probability of C happening. So all of those values together. So what is that? 0,15 plus 0,05. Let me quickly work that out. Plus 0,16 plus 0,2, right? Those four values all together. That is 0,56. That is the probability of C. And when we need to find the probability of B, that is going to be all of this, right? The entire B circle. Okay, so we're going to say 0,1 plus 0,16 plus 0,2 plus 0,183. You add all four of those values together, and you are going to get 0,643. All right, so the probability of B is 0,643 times, what did I get for the other one? I think it was 0,56. Let me just quickly check that. Yes, I am going to upload this to my YouTube. Sorry guys, I calculated the wrong one first. So let me just quickly double check that number. 0,56, yes, absolutely. All right, so for the second calculation, it's very important you do these two probabilities completely separate. All right, the first one is where the two overlap. The second calculation is the two values separately. So now when we multiply these two together, we are going to get an answer of 0,643 times 0,56. An answer of, ooh, okay, so this is now 0,36. Let me just show you what's happening on the calculator. It's not exactly 0,36. It's 0,36008. But if we round this, it is the same. All right. And on the memo, they do actually have them as being the same. So now if these two values are equal, the probability of B and C is equal to the probability of B multiplied by the probability of C. That means that these two events are in fact independent. Guys, you have to know how to do this because this is a straightforward calculation. The calculation will always be the same. You have to know how to find the AND probability, and you have to know how to find the separate probabilities, and then you have to know that you must write those two last statements. So in terms of marks here, you are going to get a mark for the probability of B and the probability of C separately, right? So for recognizing those two probabilities, you get a mark for this probability of the overlapping part. You then also get a mark for multiplying these probabilities together, and then you get your final mark for both of those statements. You have to state both of those. All right, this is almost like a reason in geometry. You don't get the mark if the reason isn't there. Okay, that's very important. All right, any questions at this point, guys? I'm going to zoom out so that you can take a screenshot if anyone wants to. Right, are we fine? Can we move on to the next page, the next question? Hi, Asa, don't give me a gift, man. Can I repeat 10.1? Okay, very quickly. For 10.1, they gave us 0,893. They're saying the probability that at least one of the events will occur is 0,893. Now, at least one means that either A or B or C or a combination of them could occur, right? So that is all three circles all together. So that's why the total for these three is 0,893. So if they're asking for what is outside of those two circles, or those three circles rather, you have to take 1, which is the total of all the probabilities always in a Venn diagram is 1, and you're going to subtract 0,893. That's how I got Y. Then to get x, which is this number in the middle, you're going to take 0,893, which again is all three circles all together, and you're going to subtract all of the other probabilities, and then what you're left with is the one that we didn't have, which was x. If they are not equal, yes, that means that they are not independent. For some reason, they don't like the term dependent. I'm not sure why. They prefer saying not independent, but I mean, yeah, I think it's the same thing. What if they ask about mutually exclusive? I don't know if this does come up in any of the questions that we're going to get to today, so I will just quickly write that down for you at the bottom. So mutually exclusive events are events that can't take place at the same time, right? So if you're thinking in terms of a Venn diagram, the circles will always be separate. So you will have one circle here, let's say it's a 2-circle Venn diagram, and you will have your second circle, and you'll have your box, and those 2 circles will not overlap. There's no and. Sorry, let me just fix that line. So that is what the Venn diagram would look like. Sometimes, guys, they can draw the 2 circles so that they're overlapping, but they just put a 0 in the overlapping part. They can do that as well. Now, if they're asking you to prove that 2 events are mutually exclusive, say this is A and this is B, you are going to have to show, either by calculation or just by values that they've given you, you're going to have to show that the probability of A and B is equal to 0. That means that they don't overlap. Okay, but it depends also on what information they've given you. Sometimes they give you the Venn diagram, then you can just say the events don't, or the circles for the 2 events don't overlap. But if they say show by calculation, then this is what you have to show. Then you have to say the probability of the one and the other is equal to 0. Okay, let's move on to the next question, which is a counting principle question. Again, this is from last year. All right, so keep in mind, guys, that the last counting principle question is always the last question in the entire paper. So it is generally quite difficult, right? So if you are struggling with counting principle, they usually give 1 or 2 questions that are quite straightforward, and then there's 1 question usually that is quite difficult. All right, so there are only 2 questions here. The first one is okay to do, and then the next one is more complicated. So we'll just talk about both of these. Okay, a 4-digit code is required to open a combination lock. All right, so now I'm going to say 1, 2, 3, 4. I don't know how your teachers do counting principle. I always look at how many digits in the code, for example, or how many seats in a row that you have to let people sit in, or how many lanes in the swimming pool that people must swim in, whatever, and then I'll do a little line for each of those things. All right, then what I'm going to write in here is the number of options for each of these digits in the code. And once I figured out how many options there are for each of these digits, I'm going to multiply them all together. Okay, so that's my method. If your teacher does it differently and you prefer their method, please continue doing their method. That's fine, but this is just how I do it. Okay, so they're saying the code must be even numbered. Now, guys, what this means is that it has to end on an even number. All right. If they're saying the code must be even numbered, that means like the number that you're getting when you're putting all 4 of the digits together. So, for example, 2,805 is not even numbered because the 5 is an odd number, right? But if you have 2,802 as your code, that is even numbered because the last digit is an even number. All right. Then they're throwing a spanner in the works here. They're saying may not contain the digits 0 or 1. Okay, so this entire code can't have a 0 or a 1. So how many numbers do we actually have to choose from? We can only choose a number from 2 to 9, right? We can't choose 0 or 1. So we actually only have 8 options in total. 8 numbers that we can choose from for this code. All right. Oh, sorry, that's off the screen. Now they're saying another thing, digits may not be repeated. Okay, that also is complicated things a little bit. So I'm just going to highlight that. Guys, what that means is if you are using a 5 in your first slot, right, as the first digit in this code, there can't be another 5. So we can't have, for example, 5532, right? We can't have that because there we have a digit that has been repeated. Okay, 10.2.1. How many possible 4-digit combinations are there to open the lock? So that is the first question. Let me actually number it here, 10.2.1. So now they're saying if we take all of these restrictions into account, how many possible combinations are there to open up this lock, right? How many codes could we possibly try out? How many codes could we create? Now, guys, we need to remember that there are 8 numbers to choose from, but since this has to be an even numbered code, we first need to think of what that last digit could be. So that is the most important slot that we have, is this last digit. Because if the last digit, like I said already, if that's an odd number, this is not an even numbered code. All right. Yeah, lots of people struggle with probability, guys, especially these questions. So don't feel bad if you don't like them. Let's quickly think from these numbers that we have to choose from. And guys, if it makes it easier for you, please write them all down. We can do 2, 3, 4, 5, 6, 7, 8, or 9. Right? Those are all the numbers that we can choose from. Now, how many of these numbers are actually even numbers? 2, 4, 6, and 8. Those are the even numbers. So the code can only end in one of these 4 numbers. So guys, I'm going to put a 4 in this last slot because there are 4 possible options to use as the last digit. Right, if this code ends in 3, 5, 7, or 9, it's not an even numbered code. All right, so that is where the last number comes from, the last digit, the options for the last digit. Okay, now we need to think, what did they say? Apologies. May not contain the digits 0 or 1. We've already thought about that, right? Those 2 are not in our list. So we know that there are 8 options altogether. Now, guys, let's say, for example, we are putting 2 at the end there. It's not necessarily 2, but it can be 2, right? We are taking away one of our possible digits for the next slot because digits may not be repeated. Whatever number you use in this last slot of this code, you can't use in any of the other slots. So now I'm going to go from the start, from the beginning here. There were 8 numbers to choose from. Now there's already a number at the end. So now that means that there are only 7 numbers to choose from for my first digit. Now, how many numbers are already there? 2. Now, there were 8 to choose from, right? I've already used 2. I can't use those same 2 numbers, whatever they are. I can't use those 2 numbers again. So I only have 6 options to choose from for the next digit. Now, how many digits are in this code? 3 digits. That means that from the 8, I've already used 3. Whichever 3 numbers they are, it doesn't matter. I can't use them again. So now there are only 5 numbers left to choose from for the next one. All right, so this is going to be your answer, guys. It's going to be 7 times 6 times 5 times 4, which when you multiply those all together is equal to 840. All right, what do we think about that? Why I placed 4 on the last line, they told us that the code must be even numbered. Now, for a number to be an even number, it has to end in an even number. So, for example, 8,312, right? That is an even number. Actually, we can't put a 1 there. Let's put a 4. That is an even numbered code, right? Because, I'll answer you now, Cara, because the last digit is an even number. So the last digit can only be either 2, 4, 6, or 8. Okay, I've listed here on the side all of the numbers that I can choose from because they told us that we can't use 1 or 0. So that's why there's no 0 or 1 there. All right, so I can only use 2, 4, 6, or 8. So there are 4 choices that I have for my last digit. Then after that, there are no other restrictions on any of these other numbers, apart from the fact that we may not repeat the digits. So if I've already used a digit here, right, this is the first one that I have to put down, because that is the digit that has a restriction on, okay? So now, because that number is there already, please note, guys, it's not the number 4. That is, yes, the last digit can be any even number from the option of 8, absolutely. Guys, are you confused? Am I going too fast? What is confusing you? Just the topic in general. Yes, you get 3 marks for that. So factorial you only use when you go with 7 times 6 times 5 times 4 times 3 times 2 times 1. Factorial is only when you're starting with a number and then you're multiplying it by every number before that. Very confused. Okay, should we start again? Let's start again. I'm going to erase everything. I'm going to start from scratch. All right, let's focus on getting these 3 marks, guys. We don't have to worry about the other 5. All right, we are just going to start from scratch. They are telling us that it is a 4-digit code. Okay, do we understand why there are 4 lines? 1, 2, 3, 4. Okay, yes, Franco, I'm starting again. Okay, or is it Franco? Okay, 1, 2, 3, 4. That's my dad's name as well. So 4-digit code, all right? Now they're saying the code must be even numbered. Now, I'll talk about that now. But what they're also saying is it may not contain the digits 0 or 1. So now on the side, I'm going to write, if I can't use a 0 or a 1, I can use 2 or 3 or 4 or 5, 6, 7, 8, or 9. All right, those are the numbers that I can choose from. How many numbers are there in my list? There are a total of 8 numbers. All right, so those are the options for the numbers that I can use in my code. There are only a total of 8 options, right? 8 choices, 8 numbers that I can choose. So now I have already, looked at that condition, all right, or that restriction. Guys, you have to always start with the restriction first. Now, the restriction that they are putting on this code is that the code must be even numbered. Now, if you are just thinking in terms of a number is an even number if it ends with an even digit. So, for example, 12 is an even number, right? Because 2 is even. 15 is not an even number. Yes, Cassidy, the numbers that I'm multiplying together are the number of options available to use. Absolutely. Yes, that is exactly what I'm doing. All right, so I'm putting 4 lines down because that's how many digits I can use in my code. And then you multiply the number of options for each digit together to get the final answer. Okay, now guys, the fact that they're saying the code must be even numbered means that that is putting a restriction on my last digit. The last digit has to be one of these 4 numbers. It either has to be 2 or 4 or 6 or 8. That will make the whole number even. Yes, CJ, large even numbers end with even digits. Exactly. You can use any other even number. Yes, absolutely. The number that I'm putting here is not the actual number in the code. It's the number of options that I have in the code. There are 4 even numbers in my list. That's why I'm putting the 4 there. I'm not saying I'm going to use 4 in my code. Why on the 4th line only? Because if you have this, if you have 7, 5, 3, 2, that's still an even numbered code. That's still an even number. The full number is still even though the first 3 numbers are odd numbers. Only the last digit is what makes a number even. Yes, 4 is the number of choices. There are 4 even numbers that I can use. Okay, are we all right with that 4 now? I'm just going to say again, 4 is not the number that I'm putting in my code. 4 is the number of options to put in the code. Okay, good. I hope you feel better about that now. Now don't let go of that feeling of understanding now when I do the next bit. Okay, we've now taken that restriction into consideration. Now we're going to look at the last restriction. We need to look at this in order to figure out how many choices I have for the other three numbers. Now guys, it doesn't matter which number you put in first, right? I sort out my restrictions, then I think of the first number in this digit. Now guys, let's just recognize that we have now used one of our 8 options. Sorry, there's a dog barking outside. I hope you guys can't hear the dog. It's very annoying. So there are 8 numbers altogether that we can use. When you put one of the even numbers in that last bit, no, so Mish, even number just means that the last digit has to be even, not all of them. Okay, just because like we said here, this number that I have here, even though these first 3 numbers are odd, the number as a whole is still an even number. Okay, so even numbered doesn't mean every single number must be even. It just means the number as a whole. If you look at the code and you read the number out, that number must end with an even digit. Okay, so now the fact that they're saying digits may not be repeated, we have put a number in that last slot. Now, how many numbers? Let's say we put a 2 there. Okay, it's not necessarily, it could be a 2 or a 4 or a 6 or an 8. Doesn't matter. The bottom line is we've used one of our options. We now only have not 8 options to choose from anymore, 7. Because we can't use the same number more than once. So whatever number we put as our last digit, we're not allowed to use that number again. All right, now that we've put that number there, and whatever this number is, right? It could be a 3, it could be a 9, it could be a 6, it doesn't matter what this is. Yes, it can't be repeated. We now have 2 numbers that we've already used, meaning from our 8, we've taken 2 away. We now only have 6 that we can use for the next number. Right? Now, how many numbers have we now used? 1, 2, 3. From our original pool of 8 numbers, we've used 3. We are only allowed to use the remaining 5. So that is our answer, guys. 7 times 6 times 5 times 4, which is equal to 840. I'm going to let you guys just absorb that. I'm quickly going to close the door because this dog is irritating. Okay, how are we feeling, guys? Are we understanding? Do we feel a bit better? Oh, sorry. What does wakula mean? Yes, ma'am. Okay, good. Yes, we're feeling better. So when do we multiply by the number of units? That is when we're doing groups. Okay, I will talk about that still. Way better. Good. I'm so happy to hear that, guys. All right, so now you can at least get 3 marks. Now, what they are giving marks for specifically is the 4, because that was a restriction. And then they're giving marks for all the other numbers, and then, or a mark for the other numbers, and then they're giving a mark for the last, for the answer. When do you use the 1 or the exclamation mark? So you would say factorial, that's what the exclamation mark is, if you have this. If you have the 7, and then you're multiplying it by every number that comes before it, all the way down to 1. 3 out of 150, there we go. It's better than nothing. A tree diagram. I'll see if it comes up in a question. I'm just doing like past paper questions. There are some tree diagram videos on my YouTube if you want to go look there if we don't get to it. Is this the layout we must use in the exam? You can. So they're not going to give you marks for this, right? You can write whatever little notes you want on at the top to help you kind of make sense of the question. They are just going to mark the answer. So which numbers you're multiplying together and then the answer. So make sure that you're showing that. No, you can't use the exclamation mark here. So Joel, this is the factorial thing. So if they had said we're doing a 7-digit code and the digits can't be repeated, then you would just do 7 factorial. Let me just quickly see here other comments. Yes, I'm listening. Question 11.2 from November 2019. I don't know if I'm going to get to that. Let's get a move on. Oh, wow, it's already 4:45. Okay, let me quickly do the next one. Sure, but guys, the next one is tough, hey? I don't know if I must do the next one. Maybe we should do another one that is simple, and then I can come back to this more difficult one. All right, so I'm going to do that quickly. I'm going to skip this. I'm going to go straight to this one. This actually is one that has to do with groupings. So someone else was asking about when do you multiply by the number of units. So that's what's happening here. Okay, let's talk about that quickly, guys, because that is something that's completely different. I'll do the tough one still. I'll go back to that one. All right. For this one, this is November 2021. Okay, they're saying a teacher has 5 different poetry books, 4 different dramas, and 3 different novels. She must arrange these 12 books from left to right on a shelf. Write down the probability that a novel will be the first book placed on a shelf. Oh, I'm glad that I'm doing this one, guys, because this is now a different type of restriction that they're giving us. Firstly, they're asking about probability, right? Now, guys, when you are asked about probability, you need to actually do 2 calculations. You need to calculate the total number of possible ways in which she could arrange these books on the shelf, right? I will go back to 10.2.2 if I have time, but I actually have to stop at 5. So I quickly want to do this one. This is important. Guys, the problem solving ones. Now, I just want to say one thing quickly. I don't want you to spend hours and hours and hours on problem solving questions if you're not absolutely sure that you can do the more basic ones. Because problem solving, it's going to be different every year. So in November 2022, they did that one, but the year before, the questions were completely different. If you can do all the basic ones, you'll be fine. So rather make sure that you can do all the basic ones before you spend time on the problem solving ones. Okay, so I just want to show you these types of questions because this wasn't covered in the previous one. All right. So what I was saying is when they're asking probability, you firstly have to calculate the total number of possible arrangements. Yes, I'll post it tonight. And then you need to write down, or you need to calculate how many ways there are for her to arrange the books where the novel is first. Okay, so guys, let's imagine here we have a bookshelf, right? How many books do we have? 12. So there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 books, right? 12 lines, 12 books, 12 spaces on the shelf that you need to fill. Now, guys, if there are no restrictions, right? If she's just putting all 12 books on the shelf, how many different ways are there going to be for her to put those 12 books on the shelf? Well, she's going to put one book down first, hey? For the first book, how many options are there? She has 12 books to choose from, so she's going to put that book, one of the 12 there. Yes, 12 factorial, exactly. Just to make sense of it, guys, if you have actual things, right? If there's one book there, you can't put that same book in the second space again. That book is already there. So now you only have 11 books that you can put in the next slot. 10 in the next, 9 in the next, 8, 7, 6, 5, 4, 3, 2, 1. Exactly. You guys are saying 12 factorial. Perfect. That is what the answer is for this one. So this, guys, is going to be the denominator of your probability questions. Right. If they're asking for probability, this is going to be at the bottom of that calculation because that is the number of arrangements with no restrictions is 12 factorial. Okay. Now in 12.2.1, they are giving us a restriction. Now they're saying, write down the probability that a novel will be the first book placed on the shelf. Now, there is a complicated way in which you could do this, absolutely, but there's also a much easier way in which you could do this. Guys, how many books are there? altogether. There are 12 books, right? And this is also, someone is commenting, only 1 mark. That should already make you think, maybe there's a trick to this. Maybe there's an easy way of doing this, right? So just try and think of it kind of logically. There are 12 books. How many novels are there? What did they say in the question? 3 different novels. Exactly, John. So the answer to this is going to be 3 over 12. A quarter is the answer. Yes, exactly. Guys, sometimes probability also makes sense. Now for this one, I'm not going to say 3 over 12 factorial because you could do that in a different way as well, right? But you're going to say 3 over 12. If you just think, guys, imagine you didn't know anything about counting principle. You didn't know anything about factorial. If they're asking you, there are 3 novels, 12 books in total. What's the probability that you're going to pick a novel from the 12? It's almost like those questions that you got in grade 9, right? There's a bag with 12 marbles. 3 of them are blue. What is the probability of drawing a blue marble out of that bag? 3 over 12, right? So basically what they're actually saying here, what's the probability that she is going to choose out of all these 12 books? She's going to choose a novel. Since there are 3 of them, we're going to do 12. All right, that's going to be the 3 over 12. There are 3 of them over 12. Okay, I hope that makes sense. Now for 12.2.2, now we need to start thinking about counting principles. So guys, what I want you to take from this is don't just jump straight into counting principle every time. Sometimes there is a simpler way of thinking about it. Sometimes you can just think, okay, I actually can just think of this logically. There are 12 books, 3 of them are novels. That's going to be the probability. Okay. For 12.2.2, calculate the number of different ways these 12 books can be placed on the shelf if any book can be placed in any position. Guys, we've actually already done that. It's 12 factorial. I wonder what that actual value is. Oh, it's a very big number. It is 479,001,600. That is the answer. What do you mean no memo? I'm doing the memo right now. All right, so guys, on this memo, it's 2 marks. They're just saying 2 marks for answer. So I'm not entirely sure what it's for exactly. All right, I don't know if they're giving 1 mark there and 1 mark there, or if you get 2 marks if you leave it as 12 factorial, but oh, the memo for Friday. Oh no, I only see that paper after you guys see it actually. You must first get it and then we open it. So I just typed 12 factorial into the calculator to get this answer. Hi, Miss Hannah. No, please. Miss Hannacom is my YouTube name. You guys are making me laugh today. So Madonsela, I just typed this into my calculator and that's the number that comes out. Right, 12.2.3. This is now the last question in the paper, so now we're going to have to use our minds, hey? No, I can't get the paper before you guys. Calculate the probability that a poetry book is placed in the first position, the 3 novels are placed next to each other, and a drama is placed in the last position. Oh, this is very complicated. Okay, let's think about this, guys. A poetry book is placed in the first position. Okay, I'm going to do my 12 lines again. Each line represents a book, right? Oh, I lost count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Yes, grouping, exactly. Now, if they're saying a poetry book is placed in the first position. Guys, how many poetry books are there? 5. Okay, so there are 5 books that I could possibly put in the first position. Okay. So I'm putting that 5 there. This is representing the poetry books. The number of poetry books that there are to choose from is 5. Okay. Now, I'm going to talk about this 3 novels are placed next to each other just now because that is the complicated bit. But they're also saying a drama is placed in the last position. How many dramas are there? 4. So there are 4 books that I could put in the last position on the shelf. All right. Are we seeing that? Are we fine with those two values? So they're saying it has to be a poetry book in the first slot, so there are 5 options. Has to be a drama book in the last slot, there are 4 options. Okay, now guys, how many books are there left in between? Right, there are 2 books now in their slot. There are still 10 books here that can be arranged in the middle in any order. But they told us 3 novels are placed next to each other. Now guys, if we have 3 novels that are placed next to each other, they form a unit, or they form a group. Some teachers say unit, some teachers say groups, right? So let's say these 3 are the 3 novels, right? Now guys, within that group, because there are 3 of them, right? Let's say this is the group of 3 novels. In the first slot of that group of 3, I can put any one of the 3 novels. Now I've already used one of them. How many are left? 2 novels for the next slot and then 1 for the last slot. So yes, CJ was saying 3 factorial. That is one group of novels that can be in their little group. They can be arranged in 3 factorial ways, right? So this is going to be 3 factorial. That is the group of novels. I'm going to write here, group of novels. Let me take away this 10. How many books are now left for these other slots that can be arranged in any order, right? They didn't tell us anything about the others. They said poetry book there in the first place, drama in the last space, and then the 3 novels must be put together. So how many books are left? 1, 2, 3, 4, 5, 6, 7. Now any of these 7 books can go in this slot. Then I have 6 books left. Then I have 5 books left. Then I only have 4 left. I only have 3 left. I only have 2 left. And the last book is going to go there. Okay, let's see if you guys can see that. Yes, Mimi, 7, exactly. Now guys, if I look at these blue ones, right, let me highlight them. 7, 6, 5, 4, 3, 2, 1. That is 7 factorial. 7 factorial. So we have 5 times 7 factorial times, what's this? 3 factorial times 4. Now that, if you multiply it all together, oh gosh, but guys, remember this group of novels, actually, we almost forgot about those. It's going to be 8 factorials actually, because guys, I put these 3, thank you, Maimuna, that is exactly what I'm talking about now. These 3 novels, they're not necessarily going to be in this space. They can actually be anywhere, all right? So actually there are 8 kind of groups of things. So let me redraw this. We have 1 for the 5. We have our 1, 2, 3, 4, 5, 6, 7, and then our group. So we actually have 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. And then we have that 4th number there. All right, so there's 8 and 7 and 6, 5, 4, 3, 2, 1. But let's say that one is actually that group of 3 novels. So Ryan, the combination formula is not actually in the syllabus, but you are allowed to use them, absolutely. Don't we include the first and last digits? Not sure what you mean by that. Yes, someone here is saying everything over 12 factorial. So the 8 factorial is coming from, because guys, I put the group of novels here, but they actually can also move around. So those 3 books could possibly be here, or they could be there, or there, or there. So that actually is also like a unit. It's like a unit. So it's not 8 different positions for the... How can I explain this? These numbers are the 8 units, which is actually 7 books and 1 group of novels. That's where the 8 factorial is coming from. See if that makes sense. Within this 1 group of novels, because there are 3 of them, that is going to be 3 factorial. Yes, Nicholas, they can be shifted anywhere as long as they are shifting together as one group. All right, so we have a poetry book in the first slot. We have a drama book in the last slot. There were 5 poetry books, 4 dramas. And then within that, those books that are left, right, which were actually 10 of them, 3 of them go together as one group, and then there are 7 separate books that can also be shifted around. So there are actually 8 groups, 8 units that can shift around. Yes, you can screenshot now. I just want to finish this answer. So it's going to be that over 12 factorial, which is 1 over 99. There we go. You can screenshot. All right, how are we feeling, guys? For this, really, practice does make perfect. I know it's difficult. It really is something that you have to kind of wrap your mind around. I don't suggest that we do new formulas now. If you want to Google permutations and combinations, fine, but I'm worried that you guys are going to get more confused. It's over 12 because they asked for the probability that this will happen, and the total number of ways in which the books can be can be arranged if there were no restrictions was 12 factorial. So that's why it's over 12 factorial. Feeling better than 30 minutes ago. That's all I could hope for. Before 2020, yes, sure. Why not? Just don't go too far back. Don't go to like 2015, 2014, unless you have time and you have already worked through the others. Now, guys, just before I go, you have to actually prepare before you work through past papers. I know I'm working through past papers, but I am kind of assuming that you guys have done some preparation already. You can't really walk into a past paper blind, right? You need to do some practice before. So if you know, for example, you really struggle with counting principle, you are either going to go practice some counting principle. Now, guys, you can use Siavula for that. Siavula is a really good source. I'm going to write it here, www.siavula.com. You can sign up for free and you can go through their different topics and you can choose to practice counting principle. And what happens is if you get a question wrong, they explain to you afterwards exactly how you were supposed to do it and why you got it wrong. But guys, this is also only 15 marks of the entire paper. So please don't spend hours and hours and hours on this if it's not going to make you fail the paper, right? Focus on the topics that count the most. So you have to make sure you can do the algebra work. You have to focus on sequences and series. Guys, calculus and functions are the 2 biggest chapters, the 2 biggest sections in the paper. And I've already gone live for finance and for calculus. Those videos are both on my YouTube. So first make sure that you are okay with those ones before you do this. All right, so now, which maths app, before I go? Is there measurement in the paper as a topic or it's under calculus? It's under calculus. They won't test it separately. Why aren't the 5 and the 4 at the beginning and end counted as units? Because they are kind of set. They're stuck there, right? They can't move. There has to be one of those 5 in the first spot and one of those 4 in the first spot. They can't still move around. Yeah, what's this app called that you're talking about? Before I leave, because then no one can see.